You know the feeling. You've spent weeks, I mean literally weeks, meticulously tending to this tiny backyard garden. You've weeded, you've watered, you've waited, and then you're practically in tears because one single, highly motivated caterpillar just devoured your only tomato plant. Sound familiar? Well, what if I told you that over 2,000 years ago, humans actually figured out an ecosystem smaller than a cheap plastic swimming pool that produces meat, eggs, and veggies with absolutely zero chemical fertilizers? The secret isn't some heavy, complex modern tech. It's actually about doing way less and just letting nature do the heavy lifting for you.
Welcome to this Mundi explainer. You're going to want to hit subscribe right now because, let's be real, before modern global supply chains get any more fragile, you might actually need to learn how to fish in your own bathroom tub. Today we're diving into how real biology works when we just stop trying to micromanage every little detail. Because, as we always say here, simplemente humano.
Section 1. The origin of polyculture.
So, our timeline kicks off way back around 3500 BCE, right along the banks of the Yellow River in China. After the massive seasonal floods would finally recede, early farmers noticed something pretty fascinating. Fish were getting trapped in these small, muddy puddles left behind on the land. But here's the kicker. The fish didn't die. Actually, they thrived. They grew, they reproduced, and they survived perfectly fine entirely on their own. Those ancient farmers realized something crucial. They didn't need to invent complex pumps or massive machinery to keep these fish alive. They just needed to dig the puddles a little bit deeper, pack some clay around the edges, and literally just let nature take the wheel. It's a perfect example of pure observation totally beating complication.
And then, a totally ridiculous bureaucratic obstacle actually forced a massive leap in innovation. Fast forward to the 7th century, during the Tang dynasty. The emperor at the time had the surname Li. Well, in the ancient Chinese pronunciation, the word for carp sounded almost exactly the same. So, because of this simple pun, the imperial court decided it was highly disrespectful to farm, kill, or eat carp, and they just completely banned it. No way, right? Imagine being a farmer whose main source of protein for 1,000 years was suddenly made illegal by a pun. But instead of throwing in the towel, these farmers got incredibly creative. They figured if they couldn't farm one type of fish, they'd just farm several others, all at the exact same time. They mixed fish that eat surface plants with fish that eat bottom sediment, with each species living in a totally different layer of the water. And boom, just like that, the brilliant system of polyculture was born.
Section 2. The proof of science.
Jumping ahead to the 1960s, researchers at Auburn University actually put this ancient system to the test. They built experimental ponds roughly the size of a large two-car garage. Now just think about the sheer absurd complexity of modern cattle farming for a second. You need massive plots of land, thousands of dollars in feed, antibiotics, and heavy fencing, all just to yield roughly 200 pounds of meat a year. But the Auburn pond, it required zero inputs, no expensive feed, no pharmaceuticals. It was entirely self-sustaining, and yet it yielded a staggering 350 pounds of fish.
Yep, that is 160 kilograms, or 350 pounds, of high-quality protein produced every single year from a literal hole in the ground the size of a garage, and it functioned completely on its own. To really understand how this is even possible, let's look under the hood of this biological factory.
Section 3. The feather engine.
In this system, there are 4 living gears working together. The very first gear, the ducks. As the ducks paddle around on the surface, their webbed feet gently stir up the soft sediment at the bottom of the shallow pond. This actually frees up crucial nutrients that would otherwise just be trapped down in the mud. Then comes the real magic, duck manure, which is incredibly rich in nitrogen. When this nitrogen hits the water, it acts like rocket fuel for algae. The algae blooms, which then feeds the microscopic plankton, and that plankton becomes an endless, completely free buffet for the fish. So the ducks literally kickstart the entire nitrogen cycle just by swimming and digesting.
And to make it even better, a tiny workforce of just 3 to 5 ducks doesn't just power the pond's entire ecosystem, it also delivers up to 1,700 eggs a year to the family. All of this for free. You're getting this massive return just by letting a few birds do exactly what they naturally want to do anyway.
Section 4. The green filter.
Now obviously, you can't have animals eating and producing waste in a small body of water without a solid way to clean it, right? Otherwise, the water just turns toxic. Enter the second gear, aquatic plants, specifically a miraculous little plant called duckweed. Duckweed acts like a highly efficient organic vacuum cleaner. Its tiny roots dangle right in the water, aggressively sucking up excess phosphorus and dirt particles, and releasing crisp, clean oxygen. It constantly filters the water, making absolutely sure the fish have a healthy, clear environment to thrive in.
And the sheer speed of this plant is mind-blowing. Duckweed is actually one of the fastest growing plants on Earth. Under the right conditions, it can double its entire biomass in just 48 hours. Plus, because duckweed is packed with high-quality protein, the ducks absolutely love to eat it. So think about this. The plants clean the water for the fish, they grow at an insane rate, and then they serve as free, highly nutritious feed for the ducks that are fertilizing the water in the first place. It is a perfect, zero-waste, closed-loop cycle.
Section 5. The scale trio.
Now for the third biological gear, the fish. This is where the brilliant division of labor really happens. First up, you have the bluegill. They're the reproductive backbone of the pond. They spawn naturally several times a warm season, feeding on insects and plankton, which means you never have to buy new fish to restock the pond. Then you have the catfish. Think of them as the janitors. They live down in the dark, happily sweeping the floor, eating up organic matter and insects right out of the sediment. And finally, you have the tilapia. These are your rapid growth producers. Eating all that algae and plankton, a tilapia can reach nearly half a kilo, about a pound, in just 6 months. It's essentially an underwater assembly line where nobody competes and everyone helps each other out.
So you're probably wondering, how long does it actually take to build this biological factory? Well, the initial setup, digging the hole, getting a liner, buying a few starter fish, plants, and ducks, usually runs between $400 and $600. From there, time is pretty much your only real investment. At 6 months, the water nutrient cycles form and the roots stabilize. At 1 year, your fast growers like the tilapia and catfish hit harvest size. By year 2, those bluegill are naturally reproducing. And by year 3, you aren't really farming anymore, you're simply harvesting from a perfect, self-sustaining natural system right in your own backyard.
More than 2,400 years ago, a man named Fan Li wrote, "Nature does not need us to control it, nature only needs us to cooperate with it." This tiny ecosystem offers a kind of resilience that our fragile modern supermarkets literally never can. By just aligning a few ducks, plants, and fish, you achieve true independence. Which leaves us with one absolutely crucial question. If a simple backyard puddle can completely outsmart the sprawling complexity of modern industrial agriculture, what other brilliant laws of nature are we ignoring to our own detriment?